Hello! Welcome to Homework Help 5.3. Oh, I still have a proof on the board behind me. Anyways, once again, this is Canvas. Modules is where you should be looking. Make a good habit of clicking on here a lot. All right, I post the homework. I post, obviously, these. I post the answers. I post any notes. So, like notes, helpful things. All right. Anyways, here we go. Remember that when you write a congruent statement such as triangle ABC is congruent to triangle FGH, the corresponding parts of the two triangles must be the parts that are congruent. For instance, angle A is congruent to angle F. Okay, it matters what order you write them in. Angle A is congruent to angle F. AB is congruent to FG. AB, FG are congruent. They have to be in this order. Angle B is congruent to angle G. B, G, BC is GH. So BC is congruent to GH. And also angle C is congruent to angle H. They didn't write that one, but it's okay. Also recall that the congruence patterns for triangles, angle, side, and side, are what we use to justify triangle congruence. There's also angle, side, but that's all right. So the segments and angles in each problem below are corresponding parts of two triangles. Make a sketch of the two triangles. Where, I don't know, they didn't really give you room to sketch. Then write a congruent statement for each pair of triangles represented. State the congruence pattern, which is one of these guys that justifies your statement. All right, so I'm going to go ahead and just do number one. I think it'll make sense as soon as you see me do one. Hold on. Get my little pencil out. So I'm just going to draw, I don't know where. There's really no good place for you to do this. Maybe if we draw a little triangle. So I'll draw a little triangle here. These are going to be sloppy. Just throwing that out there. And then these have to be congruent, so pretend that these look, oh, look at how straight that is. Pretend that these are the same. How badly did I do? Second one's a little bit better. All right, so ML is congruent to ZJ, okay? Well, I'm going to say this is M, this is L. Oops. Oh, please let me write where I want to write. Okay. Oh, okay, whatever. So that's M. We'll say this is L. This is M. L is congruent to ZJ. So corresponding parts. All right, fine. I'll just use my pencil. Z. That's Z. Oh, yeah. And this is J. All right, so these sides are congruent to each other. Boom. Boom. Okay, so I took care of that. LR is congruent to JB. So back to your first triangle. So this first triangle is MLR. ML. So then R is up here. Let me see if it'll let me type it up here. Okay, yeah, well. So this is R. MLR. So LR, this line, is congruent to JB. So B is up here. Okay, so this other triangle is ZJB. Hopefully that makes sense. And then those two are congruent. So we'll put two little congruency marks. 1, 2, uno, dos. Okay. And then finally, they tell us that angle L is congruent to angle J. Angle L, okay, angle L is congruent to angle J. All right. So, congruency statement is triangle. I don't have a triangle shape on here. Triangle. I don't know. We'll do MLR. Triangle. MLR is congruent to, make sure you write it in the correct order, to triangle. So I did MLR, so I have to do ZJB. They have to match. ZJB. All right, and then is that by side, 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 or angle, side, angle? Which congruency pattern? Okay, it is by side, angle, side. Two sides and the angle in between. All right. So that's what you're doing for 1 through 6. Then, see, here are the definitions. I told you they would also be in the homework. Here are your definitions again. Same ones from the lesson. Okay, so 7, name a segment in triangle GHM that is an altitude. I think I'm going to let you try 7 through 9 by yourself. 10, create a perpendicular bisector by marking 2 segments congruent in GHM. Name the segment that is now the perpendicular bisector. Okay, so perpendicular bisector, that means it has to be perpendicular to the side it intersects, so it has to create a 90-degree angle, and then it has to cut the side in half. So it says that we're going to create one by marking 2 segments congruent. All right, so looking at your triangle here, which line looks like it could be a perpendicular bisector? Okay. Remember, it has to hit the other side at a 90-degree angle, and it cuts the line in half. So that's ED. Right, so this is going to be our perpendicular bisector. It cuts this line in half. So we're going to mark this side congruent to this side. Name the segment that is now the perpendicular bisector, ED. You should draw a line over it. I'll draw a line over it. There. Okay. 11. Okay, construct the altitude. So remember, your altitude from D to EF, okay, your altitude has to be perpendicular. Let's go back up. Drawn from a vertex and is perpendicular to the opposite side, or an extension. So this is where you're going to have to extend this side out. Okay, I'm going to have to, let me see if I can do that fairly accurately here. So we go along. Apparently I didn't do that well already. There. Extend it out. I think that's actually pretty good. Okay, so we're going to extend this side out, because right now if I drew a line from D to EF, that's not going to be perpendicular, right? It has to hit at 90-degree angle. So what do we know about, you could use a protractor technically, but what do we know about perpendicular lines? What do we know about the slopes of perpendicular lines? I'm trying to think if we went over this last quarter. You definitely had this last year in IM1. Okay, perpendicular lines have opposite reciprocal slopes. So the slope of this line is, let's see, I go up 1 and then 1, 2, 3, 4, 5. Okay, so my slope here, slope of EF, slope is change in Y, which is 1, over change in X, which is 5. All right, so then the perpendicular line is the opposite reciprocal. So you flip it and change the signs. So instead of 1 over 5, it's 5 over 1, and then make it negative. So then you can start at D, because it's going to be coming from D, and just use this slope. So negative 5, so down 5, 1, 2, 3, 4, 5, and over 1. So it should be right there. Okay. So it's coming from D because it has to come from the vertex to the opposite side, or an extension of the opposite side. Right? And it has to be perpendicular, so it's going to have the opposite reciprocal slope of this line right here. So let me draw in the line, or attempt to. So there is your altitude. The median, I think I'm going to make you figure out on your own. It's going to come from D, and it's going to hit the midpoint of this side. Perpendicular bisector of EF. So that does not have to come from D. Remember, scroll back up. Is a line drawn perpendicular to a side of the triangle through its midpoint. So your perpendicular bisector has to cross in the middle, and it has to be perpendicular to this line. All right? Try that by yourself. Here we go, this proof. Tiani has been studying the figure below. She knows that quadrilateral ADEG is a rectangle. ADEG, she knows that's a rectangle, and the ED bisects BC. ED bisects BC. She is wondering if, with that information, she can prove that triangle BGE, this triangle right here, is congruent to EDC, triangle EDC, this triangle right here. She starts to organize her thinking by writing what she knows and the reasons she knows it. Okay, so she's writing them out in sentences. What you're going to do is take her sentences and turn them into a 2-column proof. Ho, 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 ho. Okay, so sorry, I don't know what that was. I know ED bisects BC because I was given that information. So ED bisects BC. So you should write that in your proof. ED bisects AC because she was given that. Oh, I don't think she says this in her sentences. No, she doesn't. So they also gave you this. Quadrilateral ADEG is a rectangle. You were given that information as well. She knows that it's a rectangle and that ED bisects BC. So those are the 2 things you are given. You're given that information. All right. So then the next thing. I know that BE is congruent to EC by the definition of bisect. So BE is congruent to EC by the definition of bisect. So you're going to come down here. I'm going to have to make this a little smaller, I think. ED, yeah, is congruent. Make sure you draw your little congruency mark above this. Is congruent to AC. We know that because of the definition. Sorry, of bisect. Actually, I should also have lines above these. So line above that, straight line. I just can't draw straight lines. And that, and then my congruency mark. Whoa, that got away from me. Yeah. Okay. What's next? I know that GE must be parallel to AD because the opposite sides in a rectangle are parallel. So as you're reading these, I would also be making marks on your picture. So GE must be parallel to AD. So GE is parallel to AD because opposite sides in a rectangle parallel. Okay. GA. So same idea with GA and ED. Sorry, that was 80. I don't know if I said that right. GA. Oh, that definitely got away from me. 2 little arrows. 2 little arrows. So opposite sides are parallel. So if you want to write those separately, you can. You can also just combine them and say AC is, oh geez, doesn't work. I don't know how to make my parallel. I'll draw it in. AC is parallel to GE, and GA is, I'll draw it in, parallel to BE. Drawing your little parallel marks. There are 2 straight lines. That represents parallel. 2 straightish lines. Okay. Try and make yours straight. They're 2 straight lines. All right. And that is because opposite sides of a rectangle are parallel. Or you could say the rectangles are parallelograms, or yeah, one of those things. Okay. So far we have covered, we did that, we did that, we did that, Did that. Okay. Next you have, I know that AD is contained in AC. So AD is contained in AC, right? So AC is also parallel to GE. So AC is also parallel to GE. I don't know if they gave me, oh no, we can write that in the proof. They didn't write that in the answers, but we're going to write it. So, um, so AC is parallel to GE. AC is parallel to GE. AC is parallel to. Did I write that wrong? Hold on. Oh, my bad. This was supposed to be AD, wasn't it? This first one's supposed to be AD. Oh, no. Come back. Yeah. Uh-oh. Can I just erase this one letter? Thank you. I think that should have been AD. Yeah. Sorry. That should have been AD. My bad. I got ahead of myself. So AC is also parallel to GE. And we're going to throw the next one in here too, because the next one is similar. Okay. GA is contained in BA. GA is contained in BA. It's part of the same line. So BA is also parallel to ED. All right. So BA is parallel to ED. And BA is parallel to BA, goodness gracious, is parallel to ED. Okay. Let me draw in my little. GA. Goodness, I'm falling apart. This should not be a B. Okay. AC is parallel. Parallel. And then parallel. Okay. That's because AC and AC is parallel to GE. Okay. I don't know how to say this in a proof. Let me think. Explain somehow the same line. So AC is the same as AD, and EA is the same line as E, something like that. Okay. Then here's where your corresponding angles come in. Wait, too far up. Sorry. So this line, this whole line is parallel to this whole line. Let me get rid of my extra marks here. So what we have is this is our transversal, and these are our two parallel lines that intersect it, okay? These are our two parallel lines, this one and this one. So that means that this angle right here, let me draw a little mark, this angle right here is congruent to this angle right here. Okay? Because this line is parallel to this line, and they are both cut by the same transversal. So these these are corresponding angles. All right, so let's do BEG. Yeah. So then I have angle BEG is congruent to angle ECD. ECD. Okay. BEG is congruent to ECD, and that is by corresponding angles. So that is your reasoning. If I can write that. Oh, come lower. Oh, we're corresponding. Oh, geez, corresponding. Okay. I forgot what we were trying to prove. Oh, congruent triangles. Right. Okay. There's another corresponding angle, though. Can anyone tell me what the other two corresponding angles are? Ha! You can't. I'm a recording. I have another set of parallel lines. So this line, ED, is parallel to AB. And they're also cut by this transversal. Here, I can erase some stuff. Oh, I erased too much stuff. So this line, BA, is congruent to ED, and they are both being cut by this transversal. Okay, so that means that this angle is congruent okay, I'm losing my mind, to this angle. Did I just write that though? D? No, I didn't. Okay. Okay, so those angles are also corresponding angles. So now you're looking at this set of parallel lines, and you have this transversal. So GBE. Oh, they do BGE. Fine. B. No, they don't. They do GBE. Angle GBE. Angle GBE. I'm gonna skip a line so I have some more room here. Angle GBE is congruent to angle GBE DEC. And that is by corresponding angles. Corresponding angles. Woo! Alright. Go back up here. So those angles are congruent. These angles are congruent. And we already proved at the very beginning that these sides are congruent. Alright. So now with that information, can I prove that these two triangles are congruent to each other? Can I prove that this triangle right here is congruent to this triangle? Yes, you can. Okay? By angle, side, angle. Angle, side, angle. So then, triangle. I'm going out of the lines. Triangle. BGE. Oh. BGE is in fact congruent to triangle. BDC. And that is by, I'll write down here, angle, side, angle. Woo! And you're done with the proof. All right, this I think you guys can handle. You are, what are you doing? You're translating. Oh, no, you're reflecting. You're translating. You're translating. And then you're comparing, you're connecting all these lines together and comparing them. Okay, so just be careful. You're reflecting might be the hardest thing. Just remember, you're flipping it over this line. You're just flipping it over this line. So everything should be the same distance away from this line, except it'll be over here. All right. Good luck. See you tomorrow.